Section 7.2, dividing monomials. Essential question, how do you divide monomials? Alright, so our first example is simplify each expression. So we have x to the 7th times y to the 2nd over x to the 6th times y to the 3rd. So we are going to start by expanding this problem. So x to the 7th is the same as x times x times x times x times x times x times x. So I wrote x to the 7th, expanded it by writing 7x's. Y squared is the same as y times y. And then I'm going to expand the bottom. So I have 6x's, because it's x to the 6th. And y to the 3rd, so 3 y's. Now the way I'm going to simplify this is every time I have a variable on the top and the bottom that is the same, I'm going to cross them off. So x on the top and bottom, top and bottom, top and bottom. Now I have to stop. There's an x on the top, but not another one on the bottom, so there's nothing else I can cancel. Then I'll move to my other variable, the y's. There's no more y's left on the top, only one on the bottom, so I have to stop. What I'm left with on the top is just one x, so that has to go on the top of my fraction. What's left on the bottom is one y, so that has to go on the bottom of my fraction. So my answer is x over y. Alright, g to the 3rd times h to the 5th over g h squared. So I will expand the top. G to the 3rd is g times g times g. H to the 5th, so I'll write 5 h's. And on the bottom I have 1g and 2 h's. If you want to, you can line up your variables. I didn't do that on the top one, but if it makes it easier for you when you're canceling, that's definitely something that you can do. Alright, so these two g's can cancel. I don't have any more on the bottom, so I have to leave the 2 on the top. And then I have 2 sets of h's that can cancel. So on the top, I'm left with g squared, and on the top I'm left with h to the 3rd. Now there's nothing left on the bottom, so I am done. My answer is g squared h to the 3rd. You could put it over 1 if you wanted to, otherwise just leave it as g squared h to the 3rd. X to the 3rd times y to the 4th over x squared y. So 3 x's, 4 y's, over 2 x's and 1 y. Cancel, cancel, cancel. I'm left with 1 x on the top and 3 y's. So my answer is x times y to the 3rd. Alright. Start expanding. 7k's. M's, and 1p, five k's. No, not putting all the dots in between, but they are all being multiplied. 3 m's and 2 p's. Alright, so I'll start canceling. It's being a little weird here. Okay, so on the top I'm left with these 2 k's, these 7 m's, On the bottom, I am left with just this p. So my answer is k squared m to the 7th over p. All right, now we've got coefficients on the top and bottom. So I'm going to look at the negative 15 and the negative 45 and think about what number can go into both 15 and 45. Well, the biggest one that can go into both is 15. So I'm going to divide the top and bottom by 15. Also, negative 15 and negative 45 and negative divided by negative makes a positive. So I'm also going to change my fraction into a positive. So negative 15 divided by 15 would be 1, and 45 divided by 15 would be 2. And again, I'm making it into a positive 1/2 because a negative over a negative makes a positive. Then I'll expand. 7 x's eight y's and 4 z's. Then on the bottom, I've got 3 x's, 5 y's, and 3 z's. So I'll start canceling. All right, so on the top, I'm left with 1, 4 x's, 3 y's, and a z. And on the bottom, I'm left with just a 2. So my answer is 1 x to the 4th, y to the 3rd, z over 2. Last one. Once again, I have coefficients in both of my fractions, so I'm going to think about what can go into both 9 and 18, and that's 9. So negative 9 divided by 9 is negative 1, 2 h's, and 4 k's. And now since this one's shorter, maybe I'll put my multiplication symbols in there. And on the bottom, 18 divided by 9 is 2, 5 h's, 3 j's, and I'm actually going to put the j's over here because I've got k's as well. And I'll line up my k's. Okay, start canceling. All right, and what I'm left with on the top is negative 1, and that's it. On the bottom, I've got 2, 3 h's, and 3 j's. So negative 1 over 2h to the 3rd, j to the 3rd. Summary.